Okay, welcome to Dakota Prep's video on applying correction and adjustment factors to conductor ampacity, which is also known as derating. Derating our conductor ampacity. So we're going to use this question over here on the right to tackle this subject. It says the ampacity of a size 4 AWG THW insulated conductor is when installed in a conduit with 3 other current carrying conductors of the same size and insulation in a location with an ambient temperature of 98 degrees. Okay, so there's a lot going on here. First of all, very first thing, we need to figure out what is our conductor ampacity in general. Okay, so we've got a copper conductor, it's size 4, it's a THW insulation. Since it is in a conduit with 3 other current carrying conductors, then that means we're going to use table 31016. So we turn to our old faithful table 31016 here, and we find THW. Well, it looks like THW has an insulation rating of 75 degrees, so we cruise down the 75 degree column until we get to number 4, AWG, and it looks like, well, to start, we have a conductor ampacity of 85 amps. Okay, so that's going to be the first place we start. Oh, let's get rid of this. So our conductor ampacity for number 4 THW insulated copper conductor is 85 amps, but there's a couple of problems here, right? The problems are, first of all, it's 98 degrees Fahrenheit. That's definitely higher than 86 degrees, so we need to apply a temperature correction factor. So we go look at table 310.15B11 for our temperature correction factors. Remember, that's the top table. We hardly ever use the bottom table. Top table, B11, not B12. We find 98 degrees. Since they gave us our temperature in Fahrenheit here, then we need to look on the very far right side of our, or very far right column, that is anyway, of the table, and we cruise down until we get to 98 degrees. Okay, 96 to 104 degrees. Bingo, we fall in that category there. And then we remember, okay, THW has a rating of 75 degrees Celsius, so we have to be in the 75 degrees Celsius column. That gives us a grand total correction factor of 0.88. So, okay, so now what we got to do is apply that 0.88 correction factor to our conductor ampacity. So we say, okay, 85 amps times 0.88, this is 74.8. So our conductor ampacity is now 74.8 amps. So we got one other issue that we need to tackle here, and that is that we have 3 other current carrying conductors, implying that there are 4 total current carrying conductors in this conduit. So we need to apply our adjustment factor, which takes us to table 310.15C1. Let's get rid of this right here. You, sir, I'd like for you to go away. So we look at table 310.15C1. See, okay, we do have more than 3 current carrying conductors. We have 4, so we're going to be in this very first row, and so we need to adjust down to 80% for our number of current carrying conductors. So all we need to do is now multiply this 74.8 by 80%, and we wind up with a grand total conductor ampacity of 59.84, which means our green light winner here is the top option, 59.84 amps.